again, thank you all for being here. Today we had planned to discuss applications for basalt and composites and in ballistic. The gentleman with Smarter Building Solutions, I'm pretty sure it is, systems. I never get it right. Smarter Building Systems or Smarter Building Solutions. I always get it wrong, but it's one of those two. He's not here. He's actually was up in Canada and he got stuck in bad weather, so he was not able to present. I've worked with him extensively over the past year or so. So what we're going to do is we're going to open up and discuss these applications one-on-one. There won't be a presentation, and Mr. Brian Crowley, who also works with Nick, is here as well. We both have a good understanding, and that conversation is going to pretty much revolve around what your applications are, what your needs are, and we just want to capture those so that we can pass them on to Nick. There will be a presentation by Nick. I believe it's going to be the second Wednesday in December is what we rescheduled for. After that, we're going to discuss one of everybody's favorite topics up and coming is quantum computing. We have Dr. Sunil Dixit is going to be presenting. That will probably start a little bit early, and we're going to extend that because people do show up for just the topic of interest. So I don't want them to I don't want to do this early and then miss out the people or cut out the people that were planning on being here for the second half. And a couple other highlights. So the forums will shut down from mid-December to mid-January. So we have the first 2 weeks, the 4th and the 11th of December, we have forums. After that, there will not be a forum again until January 22nd. We do this for several reasons. One is allows me to do my end of year stuff. It also, a lot of people within the federal government, which is a huge portion of our community, are in their holiday leave and their use or lose leave period. So really to do presentations during those timeframes, it's not as beneficial to the presenters as it could be. So those are the reasons for that. Also, there is no forum next week because of the Thanksgiving holiday. So that is all my business stuff. Steve, go ahead. You had a question? Mr. Moretto? You're muted.
Can you hear me now?
I can.
Okay, beautiful. So this is a little bit different than last week's basalt discussion, or is it sort of a continuation or hybrid?
Well,
so that's the first question.
Yeah, so the idea was that, you know, we've had basalt presented before, and there are 50 different places where you can use basalt. You can use it in construction, fabric, insulation, so on and so forth. And so what we wanted to do is we wanted to get more focus, have several presentations that are more focused. So last week, the presentation was on fireproofing and insulation applications. This week, the idea was to focus around composites, you know, as using basalt as an additive to different types of composites, as well as its applications in ballistic, anti-ballistic. So, you know, using it on the hull of a craft, on the fuselage, those kind of things. Also, I know there's interest in using it in fabrics to with ballistic properties.
Okay, well, I got a couple, maybe a couple thoughts in the question, if that's okay.
Absolutely.
So, I've been thinking of trying to find different ways to replace shipbuilding with newer, better materials. Sort of take a leap like the leap was made from wood to steel in building, constructing a ship. So my one thought is, I guess the question is to what extent could we build a hull out of basalt? What would that take? So that's I guess the question. And then as you've been going through these online forums with these different applications of basalt, and I think next month you're gonna have Dr. Goodman talk about carbon nanotubes and his type of technology, which is also maybe good for shipbuilding. Um, I was just talking to somebody about maybe having a live event somewhere near the Pentagon where we could get higher level people sort of from the industrial base type of areas in the Pentagon to learn about the technology and actually talk to them about programming money with forethought into replacing, steel and aluminum and shipbuilding with materials like that. So I don't know if anybody, so we'll be having discussions on how to do that, who could sponsor an event like that, and February, March time frame. Anyways, that was it. That was the thought. Over.
Okay. No, that would be great, and I'm sure Nick would be up for it. Uh, my understanding is that just to create like a basalt panel, I don't know that 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 would be an option. In most cases, you'd be looking at adding basalt to some sort of a composite. Brian, can you help me with this? That 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 that
Yeah, you can mix a basalt fabric, mineral, paint coating, or fiber with
that
virtually any construction material in existence.
that
Basalt has been bonded to hypersonic aircraft wings with a bond strength achieving a level of 16, which is actually a higher strength than the stainless steel material itself. So
that that
the NASA has put so much
that that
effort and research and certifications in using basalt in space that using it down here on the ground becomes rather easy. And Nick's factories allow it to be mass produced at very low cost, which then starts to replace aluminum and steel and fiberglass and a variety of structures.
that that
One website that could be very useful to look at is called AIT Composites, and it's a bridge building company that we're converting over to build bridges with basalt, and we can do giant aircraft hangars with basalt. There's
that
some great pictures on how to mass produce 100-foot long structures with just a few people and simple tools and a few dollars worth of materials.
Oh, cool.
And that the concept of building a giant bridge beam is almost the same as if you were going to build the hull of a boat.
that
Ah.
any fiberglass boat manufacturer could immediately use Basalt the next day using the same tools, materials, glues, machines, everything. You could just convert it over to Basalt. And what you would do is you would try a little Basalt and then a little more, and then other variations of more and more. Then you might start using steel, aluminum, other materials to find the structural strengths that you're looking for that particular product.
And Steve, that's what we were hoping to accomplish by teaming up with Bill, because Bill has expertise in composites, and so it's going to take some testing to find that sweet spot. Currently there is a Basalt rebar, there's a Basalt mesh. I have, Nick sent me all of those different products, but these are basically different sizes of the rebar. So there's no reason why we couldn't make angle iron or things like that with this.
Okay. What about how we currently add exotic metals to steel and aluminum to make it stronger, like in alloy. So is that what you're talking about when you make a basalt rebar? It's the salt is sort of in the metal, sort of melted in there when they mix up the steel, or
so for the Basalt, it is a Basalt fiber and some sort of an epoxy.
okay, it's
but
the rebar into the epoxy,
yeah. So but the benefits are that it's more flexible. It is much lighter weight.
Okay.
Other things is when you get into different applications like space, carbon nanotubes, carbon fiber is very brittle in space. The Basalt doesn't have that problem. Benefits to using it for a ballistic application is it's hydrophobic. It does not promote mold growth or bacterial growth. It does not promote sea growth.
Okay. Well, has anybody ever tried
Excuse me?
mixing it with steel?
Excuse me, do you have any pictures that you can show us? And
yeah, let me Brian, if you wouldn't mind bringing up some of Nick's website or his blog where you can do that.
Yeah, one image worth 1,000 words. So.
Oh no, exactly, and that's one of the one of the things that I promote on here is when we have the presentations is for them to be graphics heavy.
Thank you.
So while you're doing that, so how many Basalt, I don't know what you call them, factories or, where they're fabricating Basalt, how many are in the U.S. and where are they?
I don't know that there are any in the U.S. now. I know that there's one that's supposed to be being constructed in Michigan. Brian, could you know more about that than I would?
So currently, most of the Basalt experts were in Eastern Asia, and with Nick, he's going to be able to bring full and total control of a domestic supply from like A to Z, and his companies will also be the most advanced and the largest. And there are sailboat manufacturers, surfboard manufacturers, tennis rackets, winter skis, clothing. There's a lot of different companies use his products. And if you wanted to build a Navy boat, there's virtually almost no hurdle or challenge to doing so. Almost all of the research you'd ever want's already been done by someone somewhere. And but Nick's company will be the largest and most advanced, far beyond, I believe, anything that China could do.
And it's going to be in Michigan.
So one in the current factory in Michigan, it's massive, and then another in Mexico and Canada, and then possibly South America, and then I believe there may even be teaming up like in India. I know that there's a lot of real good entrepreneurs over there.
Okay, so the one in Michigan is already up. How many are up?
It's halfway up.
Okay.
Yeah.
How much does it cost to make a factory like that?
100 million.
Yeah. Oh, okay. Are you getting help from the region to build there? Is that why you chose the location?
I can't speak to any of the reasons why or any of the financing or anything. I don't know about any of that.
Oh, okay. Yeah, because I was thinking, thinking that Florida has like this matching hurricane fund.
Mm-hmm.
And so if there was going to be a second thing that would be more
that would be a
Navy
good idea,
focused.
Steve.
Yeah.
Like I'll go ahead and put Nick in touch with Jason, Papa Photos.
Yeah, he's working on something, and sort of that's sort of synergistic with this. So yeah, great. Well, thank you for entertaining me for a little bit.
Oh no, that's fine. So there's a couple questions in the chat. Joe Schnecker, if I got that right.
Yeah, that's right. Good. Yeah, I just wonder why we haven't seen it. They're doing a lot of rebuilding bridges in the US and all that stuff, and I think they're just going with steel. So if this is such a good industry, why is it not catching on so fast? I don't understand.
It was it was always there, but the actual uses and the properties, nobody really looked at them. The Russians did a lot with it, and they kind of kept it to themselves because of all the applications. It actually works really well in stealth because the basalt allows RF energy to pass through it. So those kind of things were really kept quiet, and until I don't know if it was the 80s, the 70s when it started gaining interest, and it's only recently become more widespread known. When I worked at Carderock at Naval Surface Warfare Center Carderock, we were looking at basalt as a spray on to attritable vessels to give them more, so they'd be more hardened. It sprays on just like fiberglass does, and they would be able to withstand fire from like armaments and things like that for a longer period of time, and they could go deeper into their area. So we had just started looking at that in 2020, 2019. So it's really the awareness of it is really new. So that's why you're not seeing it. And that's one of the things that we work to promote through the forum, is to identify these new, novel, obscure, and this falls into the obscure category, and just bring out that wider knowledge. But now there is a push. There is a lot of interest. People are seeing the benefits. Like anything else, if you're going to use it for bridge building or whatever, somebody needs to test it and verify that the properties are what people say the properties are. So that's where we're at right now.
I'd like to chime in on the end of that. So you used to be the bridging technology as well. My name is Hayden Hanna. I'm at USACE ERDIC down in Vicksburg, Mississippi. My team is the group that actually funded the development of the composite girders through UMaine, University of Maine, that then spun out to be AIT Composites. And so we still currently actively have research focused on their congressional ads that were funded for this year, focused on alternative materials, some of which are basalt, but also bonding and joining of composite tub girders for long span applications. But you talked about fielding. I think there's 7. My number may be a little dated, but I think there's 7 bridges in the U.S. that we have implemented these girders, starting with right there in just south of Bangor, Maine. I believe there's some in Florida and the Carolinas now at this point as well. Yeah, so it's definitely a growing technology.
Right.
Was that Hayden talking?
Yes,
that?
It is.
Oh, okay. So you're affiliated with Maine in research, and it sounds like you have a really good relationship with Congress to get research funding. They just started a new DERPM, and that's a government term for direct reporting program manager for maritime industrial base. Okay, so getting stuff produced for the shipbuilding industry, and there's also this big push for materials that we could use in shipbuilding that it's not dependent on coming from China or Russia or other places. So I think there's some potential. I'm putting together a plan. I'm calling it right now the Center for Innovation and Advanced Manufacturing. It started out as additive manufacturing, similar to the Navy's Center for Innovation and Ship Design, which I helped start up 20 years ago. And their goal was to have like a pipeline of, sort of naval engineers, naval architects, maintain that with research and grants and sabbaticals and stuff like that. So that's still, still a small program. It was larger when it started, but I'm thinking that, this area of basalt and, Dr. Goodman's nanotube stuff, would be sort of the centerpiece around creating this new center, sort of a sister center at Carter Rock, Maryland, where they have they create the models and float them out in a basin that simulates oceans and stuff like that. So if you could, get in touch with me, or maybe we can have another talk online about how to, include what you're doing in my plan to, as I put together charts, like what universities do we think would be part of that, whatever team, I guess you could call it.
Steve?
Yeah.
We have a multitude of universities and industry partners who are working on both civil works and military engineering development using material science, and a lot of that is alternative materials such as basalt. And so I'd love to share some of that information. We can definitely hook up offline.
So Let me
Okay.
ask you a question. I'm a supply chain expert, and
Is this
from the
Juan?
yeah, this is Juan Castro, and
Is
from
this
the
Juan
supply
Castro
chain,
who's talking right now?
yes.
Okay.
From the supply chain point of view, the main thing is cost. Cost is always the biggest challenge. So on some of the applications, very sophisticated applications, I get it. You're looking for better mechanical properties and stuff like that. But what about cost on simpler applications, like a building, like a bridge, construction, simple applications? What is the price point comparison of steel versus cobalt?
See, good thing you caught me.
Somebody needs to unmute. Vince, I think it's you. You need to mute. All right, so Brian, do you have any insight into on the construction side?
Yes. So,
I'm awake at night.
Vince,
Let me mute Vince.
So far.
I'm looking at examples of building bridges in the Yukon for some gold mining companies. So if it's almost impossible physically and financially to import concrete and steel into the middle of nowhere, then sometimes using a bridge that's made from glue and fabric makes more sense. And if that bridge lasts 100 or 200 years without needing maintenance, that also makes good sense. But if you were trying to build a bridge in a major city where concrete was very inexpensive and you had lots of companies willing to compete for the bid, then sometimes basalt does not make sense. It also matters greatly is, do you want the structure to be fireproof, waterproof, chemical proof?
Okay. But
are you going to use it for warfare? All of that affects.
So we're talking about 30% more, 60% more, 300% more expensive.
Well, for concrete rebar, I think it's usually about 3 times more expensive.
Okay. That's okay. That's what I wanted to know.
But if you were going to grind basalt into a powder and mix it into an aerogel fabric, then you're getting an equal cost. So say an aerogel fabric's like $15 per square foot.
Okay.
And that would protect human skin literally from molten hot lava and cryogenic fluids. So then your cost performance there is amazing.
I mean, my take is that for very sophisticated applications, you need a very high mechanical properties, thermal properties. This material is an option. It's an option out there. Weight as well. I think weight is advantageous. But when you are talking about simple day-to-day applications, we're still far because the price is going to be prohibitive, right?
Correct.
Okay. So we're at the same page. And I'm asking this because
but again, there is a caveat to that, and what Brian's trying to say is that it will last longer.
Right. Okay. Longevity of the material is better.
Right.
Okay.
And then, like you said, if you're using it for rebar inside of concrete, then it might be cost prohibitive. If you're looking at it for some sort of an insulation, it is immune to the UV radiation, so it will not deteriorate where other things like roof shingles would. So then you start to have to get into your ROI, your return on investment, and
If
No, what
if
was the
you were go-
criteria?
Go ahead.
Can I chime in real quick?
Yeah, go ahead, Ryan.
If you were going to use basalt as a composite fabric and glue it in to make composite, like a composite boat, the cost of basalt is almost equal to using fiberglass, but the strengths are far more than what fiberglass can offer.
So how about in aviation applications for the skin of aircraft?
That has been used in hypersonics.
Yeah, well, pressurized aircraft, and the cycles they go through is that an application?
Pressure cycles is especially suitable. Basalt, when used as a hydrogen pressure tank or a gas tank or an explosion resistant panel, it exceeds that of what steel, carbon fiber, and fiberglass can achieve.
I guess I'm thinking as the aviation industry uses a lot of aluminum, for lightning weights for general aircraft, right? So how about as a replacement for aluminum skin aircraft?
So to keep it fair to talk about, I would say you could use basalt paint on the aluminum aircraft to make it corrosion resistant. You could apply basalt composites to strengthen the airframe in certain areas or to provide ballistics. And then you could take aerogel fabrics and tuck that into the little nooks and crannies to thermally insulate things. Different things for different reasons. And you could literally do it all over the aircraft with different products.
And I think that you're still going to need some base to the basalt. I think is what Brian's trying to get to. So yeah, I don't know that it is going to fully replace aluminum on its own. It would be like replacing an aluminum aircraft with a fiberglass aircraft. It's just not gonna work. But there are ways to lighten that aircraft by making the aluminum thinner and reducing the weight of the support structure that keeps the fuselage, that maintains its shape.
Right. So then, in other words, it would still require. I guess what I'm going with it is RCS. You probably would not improve RCS in that case, though, right? You'd make it a stronger aircraft, but you wouldn't make it a lower RCS.
No, you would lower the RCS, yes. Because that was one of the things I did at Carter Rock was I worked in that field of topside signatures. So yes, this would lower the RCS.
Okay, yeah, we probably can't get into the details, but of course there's other methods. Okay, thank you.
Okay, so I want to get back into the chat. Lieutenant Colonel Brewer, are you there still?
Absolutely. Thanks. I appreciate you guys doing this.
Oh, no problem. So are you with Air Force or are you with National Guard?
Actually, both. So I just finished up an order with Pentagon and Air Force Futures with half A57 doing disruptive technology. So I still have unofficial connections to that office and what they're working on. But more officially, I'm working with the Kelly Johnson Joint All-Domain Innovation Center out of Michigan with the Michigan Air National Guard. So I kind of got my foot in a couple of buckets. With that being said, I am very curious to see where the building is going up in Michigan because we're sprawled out all over the state. And that may be a capability that we should talk about internally to National Guard Bureau and potentially for agile combat employment concerns, other locations.
Brian, do you know the city where the factory is?
I can't speak to that. I mean, I could guess, but I don't want to do that.
Okay.
Um,
So I'm
I
taking
did-
notes here, Colonel. I'll make sure you get that, or I'll get it to 'cause I have really good relations with Nadwick, and so I can get it to you guys there.
Great. In fact, what I'll do is I'll drop my email into the chat so that if there's any questions or if anybody has any connections they want to make regarding Nadwick, Exercise Northern Strike, there's a number of initiatives that you guys have probably have heard of that I can fill you in on. So thanks. I appreciate it though, Eugene.
All right. Yeah, just great. Yeah, and we did have the Nadwick did present, and I would like to talk with you, Colonel, about how they're doing with their cyber facility that they were going to be constructing. But not here. At a later. Okay. Next is
Eugene, can I answer a question?
absolutely.
Someone was asking basically how is basalt made and how come people haven't heard of it. Back at least more than 100 years ago, someone figured out that yes, obviously you can melt iron ore to get steel, but someone decided and found out you could melt certain basalt rocks to get a very fine, thin, melted fiber that can be drawn out and wrapped around a giant spool like a thread. You can make it 1,000 feet long if you want. And then that's your fiber that you can then weave into fabrics, glue into composites, or chop up into a powder and turn it into a paint or mix it into an aerogel fabric. And so the same stuff that is used to keep the space shuttle from melting can also be turned into clothing, medical instruments, concrete rebar, body armor, like all kinds of stuff. And the steel industry purposely went out of their way to crush basalt. That's why. And only really until the last couple of years has been basalt even been affordable to manufacture. The trick is when you melt a basalt rock, if the mineral content has to be absolutely perfect in order to make a perfectly strong continuous thread. And modern technology now allows for automation and computer quality control. And then when you melt the fibers, you can sometimes add a shielding gas or a plasma arc or some sort of treatment that somehow makes that thread strong enough so that it doesn't break. The United States here in a couple of years will be by far the world's leader in this.
All right. So Joe Schnecker, you had asked about could it be used for the auto industry? I mean, yes, it could be. It could definitely be used. There is. I've been talking with a gentleman. I believe he's in the UK. Might be in Germany, but they do armored vehicles, and they're using basalt for the armored vehicles, and these aren't built for military applications. So they're, where you get into these private owned vehicles for people that you read about online, where they're paying $500,000 for this bulletproof thing that can get them out of their house and across whatever terrain safely. Hope that answers your question.
May I?
Thank you. Thank you. It sounds like beast material.
Yeah, it is.
And I'd like to add that basalt is used in heat shielding and sound damping in cars, and also sometimes as high strength little body mounts that you usually won't make out of plastic. It's an alternative to carbon fiber. It doesn't crack real easy like carbon fiber does.
So speaking of carbon fiber and plastic, is it about same? I mean, it's much stronger, but I guess could you discuss weight a little bit? I think it's pretty lightweight as well, right? For its strength.
It's a little heavier than carbon fiber, but if you laminate to the same strengths, then they end up being the same weight. So if an inch of basalt in tensile strength might equal an inch and a half or half an inch of carbon fiber, right? But then if you want impact resistance and other strengths, well, then the amount of materials end up being basically the same thickness. And basalt is roughly 6 times less expensive than carbon fiber. And when you cut and machine and sand basalt, it produces no toxins, no itchy dust. It doesn't stink. It's absolutely fantastic to work with.
All right, so Mr. Bartlett, are you there? You had a couple questions.
Yes, sir. Yeah, where does the basalt raw materials come from? Is there a domestic source yet, or is it still a Russian source?
Most of the world's gets theirs somehow, some way, the very, very raw stuff from China. Another big supplier is, I think, Tajikistan or Uzbekistan. And there's actually a harebrained idea to mass transport basalt minerals out of Uzbekistan without using Chinese or Russian railroads. And they got great basalt over there. Nick and I got a little bit of advice from Dr. Goodman earlier this year, and we applied to get basalt listed as a strategic national resource. I don't think that was taken seriously, but I think it should be, because basalt is widely used in the Ukraine war, and the Chinese are right now leading everybody. And if we can melt rocks and build a ship out of melted rocks and an airplane out of melted rocks, we should try and do it.
Yeah, but we still need a domestic source to make it affordable.
We have the basalt ore bodies are all over North America. All we have to do is get
because there are approval. Exactly. There are deposits across North America. It just hasn't been anything that people have monetized yet.
Okay.
And then you had other questions about length and fabrics.
Yeah, I mean, just, what's the length of a basalt fiber? I think you answered that it can be made in a long strand, and then I assume woven by any fiber weaver in the country that deals with composite suppliers, if there's a demand.
And that one pulled up earlier. I don't know if you saw it, but I had one of the woven patches that I have here that Nick had sent me. So go ahead, Brian.
So it can be a woven textile, like chain link fence, or you can weave it real fine, like your jeans or canvas, or you can get it very, very fine, and it's almost like silk, very soft. You can blend it with almost any material on earth, any threads, any metal, anything. And then you can also grind it up into a powder. And when it's mixed into an aerogel, the aerogel can be sandwiched in with any other fabric to then make the entire fabric fireproof, waterproof, radiation proof, germ proof, bullet resistant, etc.
Yeah, see, and here's I mean, that was a thicker one. Here's a thinner fabric here that you can actually see me through it, I believe.
Yeah, you generally need something that's got some openness to it to get resins to flow.
Exactly.
Because we all use, resin impregnation technologies or infusion technologies. Nothing's done by hand anymore.
Quick question. For the resins that are used for this, are they the same as fiberglass? Are there ones that work in fiberglass that don't work in basalt, or vice versa? Is there research into resins that are specific for basalt?
You can use almost any resin that's used on fiberglass. You can also use it on basalt. There are custom formulations, like there's one from Caltrans from California that was developed. It's a fireproof paint and fireproof epoxy binder. Non-toxic, non-flammable, recyclable, non-cancer causing, basically extremely fancy, and it's not that expensive. And it was passed and used in California, which is significant. You can customize and blend almost any formulation you could ever think of. If you want to start adding graphene and stuff that is naturally difficult to bond, then you can do treatments to the basalt to make it sticky or rough surfaced or something like that. It's better as a complementary material than when used entirely on its own. Like if I was making a snowmobile jacket, I would not make the entire jacket out of basalt. I would basically take the jacket apart and then insulate it with some basalt, sew it back together. And then I'd probably use some of the woven basalt and stitch that on as like armored padding for my elbows and gloves and stuff like that, where you need impact and abrasion resistance. Different products for different reasons at different places.
All right, so we're coming down to 10 minutes. We got a lot of stuff going on in the chat. And Brian, thank you very much for all of your help. But first, Leninmar Soto, you have your hand up?
Yes, sir.
And your question?
Okay, Leninmar Montalvo over here. I'm executive director of founder of a defense space company here in Texas. Our business partners are working in Europe with a uniform based on basalt fiber so far, and other other fibers ballistically. So far, the uniform itself stops the 9mm. 124 grains is flame retardant, and we are improving on this. There's a lot of capabilities for it. We're mostly based on military stuff, the civilian side of the house,
but are you a commercial company? Sorry, are you a commercial company?
Yes. Defense and space contracts. Yeah.
Okay.
But our business partners are getting the fibers, basalt fibers from a European company. I can't disclose nothing. And actually, they are infusing it with certain, should I say, resins, which is strengthened about close to about two times the strength of steel, and it's ongoing. So there's a lot of potential for this out there.
All right, thank you. I'd like to connect with you. If you wouldn't mind putting your email in the chat, sir. There are people within the U.S. Defense Industrial Base that are interested in exactly what you're doing, and I would like to make those connections. So please put your if you wouldn't mind putting an email contact in there, and I'd like to follow that up with you later.
I'll send you a DM on LinkedIn.
Sounds good. That works.
Roger
Was that all you had?
Yes, sir.
All right. Hey, thank you for the comment. Thank you for putting that up, because that's definitely something that's going to be of interest. So
yes, sir.
Going through the chat. So John Walker, you're asking about fiber.
Hi, Eugene. Yeah, I was just curious only because it's unclassified now, we all know. The Nordic underwater fiber optic line was cut. Most likely by the Russians. However, the Atlantic fiber optic line cross Atlantic from U.S. to Europe is right now just basically the same thing Verizon has hooking up to my house, just laying on the ocean floor. Could this be used to strengthen the fiber optic cross Atlantic line?
Yeah, absolutely. I mean, and I know that I've worked with the Air Force before, and with some chainmail style fiber, so that you could run it over with a deuce and a half and it wouldn't break the fiber, because the chainmail jacket protected the fibers inside. But this could definitely be used as a coating for not just the fiber, but for other cables as well. And it would be, again, it is immune or prohibits marine growth. I don't know that it's immune to marine growth. It's also has phenomenal UV properties. So if it is running on a telephone pole or whatever exposed to UV, it would definitely be of benefit.
Okay.
And then
awesome.
It would also work in anti-rodent applications as well.
Right. I just know that it's all over the news. It's everywhere. After that line got cut, everybody's freaking out that the Russians are going to cut the fiber optic lines between the U.S. and Europe right now. So
right.
I figured it was a value add question to the conversation.
All right.
Thank you.
Yeah. No. Thank you.
May I add that on Nick's website, he specifically has, under his blog section, a story about electrical power lines at ground level used with basalt. And they're put power lines on the ground that are safe to walk over. So they've definitely been used for high voltage transmission lines, and water ice doesn't cling to it. And it has almost no thermal creep in the sunshine and the cold weather. So there's no sag in the power line.
I did not know, Brian.
The lifespan is many times that of what you can get from rubber or synthetic coat jackets, because basalt is UV immune, waterproof, everything proof. The bugs don't bother it. Forest fires don't bother it. So.
Yeah, so I've got his blog up here. It's all part of the. I'm going to put this in the chat, but you already did that, Brian. Sorry. And this talks about covering a skiff with laminated with basalt fabric. Here's a Mercedes GLE using a basalt fiber. But we've looked at all kinds of applications where on boats that like the special forces boats that beach themselves quite often, and using this to protect the hull of those.
If you notice on the right side of this screen that you have open, there it gives you a list of categories.
Right.
This happens to be the most useful place to find things. We're just this screen right here. The website does need to probably be redone, but if under the categories you can search basalt by industry, construction, manufacturing, marine, prosthetics, sports, etc. And that really digs down into specific individual products.
Yeah, because it goes in the sports. I know we've talked about tennis rackets and different things like that, golf clubs, and all kinds of stuff. So we're running out of time here. We got a lot in the chat I want to cover because I don't want to cut into Sunil's time. Dr. Dixit, the Caspian Sea.
That was me, Eugene.
Okay, so
when you were talking about Uzbekistan, trying to get it out of Uzbekistan, around China and Russia. Most of my career is in maritime stevedoring, and I happen to have lots of connections with the Caspian Sea Alliance. Mehmet, who is the chairman. That's one way you could bypass Russia and China and get it out of Uzbekistan. There is a deep water port that you could just literally throw it on a barge and skip over.
I'll follow up with you after this to get the details on that. Vince, can you unmute? I want to chat with you. So my contact within the defense industrial base, I don't have a maritime industrial base, but I do work with the defense industrial base, and my contact is David Koch, who is the director of DLA R&D. We work pretty close together.
Hopefully I unmuted because for whatever reason can you hear me?
No, it wasn't you before, but yeah, I can hear you.
Okay. So this is submarine industrial base. Dr. Weiss-Boss reports directly to the White House. They're looking at defense industrial base type stuff. They started out focused on submarines, specifically because of concerns that we didn't have an industrial base to do some of the new generations of submarines like the Columbia. A lot of those suppliers have dried up. So they've since expanded to maritime industrial base. And he works a lot with additive manufacturing, some alternative ways to create forgings, castings, alternatives to some of the steel industrial base that we've lost as a country, specific to maritime use. So I think I'll reach out to them independently if you haven't engaged with them and see if this is on their radar, because I think it'd be of high interest to them. Over.
Yeah, no, great. That would be perfect, because I have reached out and I've introduced Nick to my contact at the board of directors for Blue Forge Alliance, and trying to get them to look into the spray-on insulation and things like that in construction of the new fleet of subs. And I understand that Blue Forge is also getting into shipbuilding now. So
yeah, Blue Forge Alliance is actually a subsidiary of Maritime Industrial Base.
Right, exactly.
Yep.
All right. So then, the last one. So Joe Schnecker had asked if it can be used as a radome. It is a perfect material for radome because it allows the RF to pass through. So anybody else that wanted to know about that, it is immune to RF, I would guess, or all right, that's the right way to say it. Jeremy, can you help? Jeremy Tootin, can you help me out here? All right.
Sorry, say that again.
So it allows RF to pass through, and I wanted to say
it's RF transparent.
There we go. Thank you.
There you go. Yeah,
that's what I needed.
Sometimes the words escape us.
Exactly. Okay, so that's everything I had. We are into Dr. Dixit's time. So I am going to stop sharing. And I want to thank everybody. I love the engagement. I was kind of concerned that we wouldn't have the engagement that we wanted with Nick being unable to show up, but I appreciate all the input, all the questions, all the comments from the community.